All right, good morning. Happy Tuesday. Glad you're able to make it. A couple of announcements. Okay, first of all, I am sending out failure notices on Friday. I'm sending a failure notice if you have more than 2 absences. I'm sending a failure notice if you're not turning in your assignments, and I'm also sending a failure notice if you're getting low test grades. Now, it does not necessarily mean that you're failing. What it means is that it's a wake-up call, like get with it or you could fail. So let me assure you of one thing: you cannot fail a class on one exam. So a lot of you did not do good on the first exam, and that's not going to cause you to fail this class, though. At the end of the semester, I do throw out the lowest exam per student. What it does mean, though, if you continue to get low exam grades, you could possibly fail. So you really want to watch what you're doing. It's more of a wake-up call than anything else. Also, you want to make sure that you're legitimately doing the assignments. I've been looking at the scratch paper that some of you turn in with the exams. It's unacceptable. So you're not writing the problem, you're not showing the work, you're just writing a bunch of garbage. And I feel bad because any classes you take in the future, you're just setting yourself up for a disaster in those classes. So you want to make sure that when I get on the board, I'm modeling what I want. You should be doing that. So you should be showing the problem. You should be showing the work from beginning to end. Also, what I'm noticing is students are getting 100, 100, 100, 100, 100 on assignments, but you're failing tests. That doesn't compute. So that means you're either one, not legitimately doing the assignments, or you're just giving yourself 100%, or you're not doing the work online. So I'm warning you, you better watch it, because the grade will turn out to not be what you expect. So the exam grade is 60% of the grade. You have to do the assignments. You do have to show your work. You do have to work the problems online. And if you don't, you're gonna stay in the situation that some of you are in, which is not a good situation. Also, I've been making parent phone calls, and I just want you to know that we have been working distance learning since August. I think like August 7th or something. I expect your devices to be working, okay? So some of the parents are saying, well, you know, their audio doesn't work or their video doesn't work. And I'm just letting you know what I'm saying. I'm saying it's unacceptable. We've been in class since August. I expect the devices to be working. If the devices are not working, you should go to the school and get another Chromebook. You should be contacting the high school. You should be contacting the district. It's unacceptable to have things that are not working at this point, because we've been in school since August and I expect things to be working. I'm telling the parents this. So I'm telling you, I expect you to show up for an exam. I expect the devices to be working. I expect it for everything to be charged up. There's no excuse for them, in my opinion, for them not to be, because we have been doing this since August. If you disagree with me, just let me know. We can have a discussion about it. But this is unacceptable, what some of you are doing, especially since you are young adults. You're going to be driving pretty soon, and you're going to be going to college pretty soon. Enough of fun and games. Get with it. All right, now, you've had 5 or so days to work on assignment 2-6. So we're not spending time on 2-6 today. I'm teaching a new lesson. So hopefully you did not do what I told you. Don't mess around for 5 days. Make sure you're doing the assignment so you have questions for me. Okay, so I am teaching 2-7 today. I'm only teaching part of it. Anybody want to ask me questions about 2-6? So hold on 1 second. Hold on 1 second. In 2-6, I posted this, but this is what you should follow to graph rational functions. If you're not following this and you're just doing your own thing and you're just putting it on the calculator, well, good luck, you know? I mean, good luck with that. I hope everything works out for you. But this is the list you should be following for graphing rational functions. I posted in materials. All right, go ahead, Mark.
You always said we have to find the domain first, right?
No.
No?
In the book, the first problems in the book were that when you're graphing the rational functions, you have to find the symmetry, the y-intercept, the x-intercepts, the vertical asymptotes, the horizontal asymptotes, plot some points and graph. So this is what you're doing when you graph. But in the first part of this lesson, yeah, they wanted you to find the domain, but I didn't put the domain on this for this. You can find it if you want.
All right, thank you.
So what I'm mainly asking you right now before I teach the next lesson, do you have any questions about symmetry, y-intercept, x-intercepts, vertical asymptotes, horizontal asymptotes, or plotting points in order to graph the rational function?
No, I don't think so, no.
Well, there's two objectives in this next lesson 2.7, and it's solving a polynomial inequality and solving a rational inequality. Now, I have 2 sheets for this, but I'm only going to teach one today. So I'm only teaching steps on solving a polynomial inequality. I just posted that. You probably just got it. So these are the steps that you want to follow for solving a polynomial inequality. Okay, so I'm going to talk about a couple things, then we're going to work a bunch of problems. All right, if you have any questions, make sure you ask me. The other thing is, if you're absent, if you have to be absent, like there's a death in the family or you have COVID or something, you must watch the video. I noticed that a lot of you are absent. You don't watch the video. Do you realize the damage that's causing to your grade? Because you can't skip a class in this class. If you skip a class, you just missed a whole bunch of stuff. You can't be absent in this class. So if you have to be absent, you must watch the video. If you don't, well, no wonder we're having trouble. Because I'm trying to fill gaps and holes. You're creating gaps and holes by being absent. All right. In this lesson, we're looking at solving polynomial inequalities. So solve means find the variable. Polynomial means many terms. And inequality means greater than or less than. So the first thing I want to talk about are these inequalities to make sure you don't mess them up. All right, so first of all, the function may be less than 0. Don't mix this up. This is less than. Or the function could be less than or equal. The function could be greater than 0. Or the function could be greater than or equal to 0. Let me pin myself so I can see what you're seeing. All right. Now, you cannot mix these up now. So let me show you how to memorize them. So a student showed me this. 1 dot is less than 2. So 1 dot is less than 2, so that's less than. 2 dots are greater than 1, so 2 dots greater than 1 is greater than. So I'll show you again. If you have 1 dot and 2, 1 is less than 2, that's less than. If you have 2 dots, 2 dots is greater than 1, that's greater than. Do not mix them up at this point. If you mix them up, everything's going to be messed up. All right, now, like I said, I posted these. Well, it's in your assignment, which I'm not going to post today because I'm not going to finish the lesson. But I posted this in your materials. So you have these steps. So let's try, we're going to do a bunch of problems. Now, every single person in here should be able to do this. So if you've been with me since August, you should be able to do this. If you have any questions as we go through this, make sure you just shout them out. So they're going to say solve, which means find the solutions, and graph the solutions. All right, here's problem number 1. So this is a quadratic, and it's saying that it's greater than 15. So if you look at my list, I said to make one side 0. So I said bring all the terms to one side. So somebody said, well, what side do you put them on? And I always put it on the degree side. Because if I subtract 2x squared, then I have to multiply both sides by a -1 and the symbol has to flip. Just put it on the degree side. So subtract 15, so this is the first step. So subtract 15 from both sides. So you get 2x squared plus x, subtract 15, subtract 15. So that's step number 1. Okay, step number 2 says we want to solve for the equality. So now we're going to change that symbol to an equal. And I'll tell you why, and I'll explain it again later. Listen, when you have an equal, you're going to have 1 or 2 solutions. When you have a greater than, you have infinite solutions. So listen to what I'm saying. When you have an equal, you have 0, 1, or 2 solutions of a quadratic, right? Remember, where does the quadratic cross the x-axis? It could cross once, it could cross twice, or it may not cross at all, right? So either 1, 2, or 0 solutions. Well, that symbol means there's infinite solutions. Well, we're not ready to find infinite solutions. We want to find just the solutions. All right, so now, since we're solving a quadratic, we want to factor. So this looks like factoring method 6. So we want what's going to multiply to give -15 times 2 is -30, and add to give the middle term, which is 1. So it's going to be 5 times 6, where the 5 is negative. So I'm going to do the problem over here. You're going to bring down the 2x squared and the -15, and you're going to put the factors in. I'm going to put 6x with 2 and -5x with 15 because they go together better. It's like Sesame Street. Who does the 2 go with? 6. Who does the 15 go with? 5. Okay, now we're going to do grouping. 2 by 2. So you bring out a 2x times what is that? 2x times what is that? 3. Now I'm going to take out a -5 times what is that? -5 times what is that? So see how the cakes match? So our product of factors is 2x minus 5 times x plus 3. So if this was an equation, what are the two solutions? Go ahead, I'm listening.
-3.
5/2.
5/2, thank you. Okay, now, guess what? These guys are not called solutions now, they're called critical points because we have to solve an inequality. So these are called critical points. And if we were solving an equation, we'd be done. But we're not done because we have to solve an inequality now. We have to find infinite answers. So here's what we're going to do. We're going to, in step number 3, look what it says. It says you're going to use the solutions as critical points that separate a number line into intervals. So watch what I'm going to do here. I'm going to draw a number line. Okay, remember 5/2 is 2.5. So at -3, this is not an asymptote, I'm just dividing the number line up. I'm going to draw a critical point at -3, and I'm going to draw a critical point at 2.5. Okay, now guess what we're going to do? We're going to test these 3 different sections. So see the sections divided by the critical points? So there's a section here, which include the numbers -4, -5, -6, -1,000,000. In the middle are the points -2, -1, 0, 0.1, 0.01, 0.001, 1.5. So there's infinite points in these intervals. Over here is 3, 4, 5, 6, 7, 8, 9, 100, 1,000,000. So what I'm going to do is I'm just going to pick a point. Don't pick a critical point. I'm going to pick 0 because I like it. So I'm going to put it into this. So I'm going to ask myself 2 times 0 quantity squared plus 0 minus 15. Is that greater than 0? Is that true or false? 0, 0 is -15 greater than 0. That's false. So I'm going to put an F there, and that means that those things inside can't be solutions. So now I'm going to test a number over there, like 3, into this. So 2 times 3 quantity squared plus 3 minus 15. Is that greater than 0? Now I'm expecting it to be true, but let's see. So we have 9 times 2 is 18 plus 3 minus 15. Is that greater than 0? Is 21 minus 15 greater than 0? Is 6 greater than 0? True. So where is 3 over here? True. Now, true means there's solutions. Now, I want you guys to think about this. This is true, false. What do you, just guess, what do you think this is over here if I tested -4?
Probably a false.
It is. It is false. No, it's not false. It's not false. True, alternating, true, false, true. And I'll tell you why. This is a quadratic. So if we drew it in 3-dimensionals or 2-dimensionals, there's your quadratic. And what this means is that if we had a y, this would be shaded on the outside. And what this means is this is true This would be open on -3, shaded to the left, and open on 2.5, shaded to the right. And now we're ready to write our solutions. So our solutions are -infinity up to -3 open, or open on 5/2 to infinity open. Because that's where the solutions are. The solutions are outside the quadratic. And if they want you to draw a graph. So the graph you're going to draw, -4, -3, -2, -1, 0, 1, 2, 3. Is going to be at -3, open with the parenthesis to -infinity, open on 2.5 to infinity. So they're asking you to solve and graph. That's the solution set. That's the graph for the solutions. And these are infinite solutions. Because you have -4, -5, -100, -1,000,000, -1,000,001, -1 trillion. So this represents infinite solutions. Now make sure you shade in. So this up here is always going to alternate true, false, true, not all the time. But a lot of times it does. And I'm just telling you, this is a quadratic. So if we drew this in 2 dimensions with an X and Y axis, if this part is shaded, that part's shaded because it's outside the parabola. Okay, so let me go over the steps again. The first thing you do is you put a 0 on one side. So that's what you saw me do. You saw me subtract 15, there's my 0. Then you saw me set the function equal to 0, number 2. So I set it equal to 0 and I solved using factoring, and I got these critical points. Then what you do is you use the solutions as critical points to separate the number line into intervals, which I did over here, and you do these tests to see which are true and false. If it's true, it means they're solutions. If it's false, no. So let me explain this. That means every point in here fails. 0 fails, 1 fails, 0.1 fails, 0.01 fails, 0.99999 fails, 1.5 fails, 1 3/4 fails. All of these inside fail, and all of the ones on the outside work, which mean they're solutions. So after you do all this, these are the 2 answers they want. They want a solution set. You can put it in a solution set if you want. And they also want the graph of the solutions. Okay, go ahead. I'll take questions, and then we'll work another problem.
Can you test different numbers, or does it have to be the same ones, like 0, 3?
You could test any numbers you want. You just have to pick them in these intervals. Now you're going to always see me test 0 because I like 0. So if the critical point is not 0, I'm always going to test 0 because it's less work. But you could test, you don't have to test 0. You could test 1, you could test 7, you could test negative, whatever you want to test. I would pick easy numbers though. That's a good question. Any other questions before I erase this? We'll do another problem. Okay, well, let me me just say something. See this greater than? Greater than means you use open parentheses in the solution and the graph. If this has an equal in it, you have to use a bracket, and you would use a bracket in the graph. Close means bracket. Open or greater than means parenthesis. Now, if I were you, I would start asking questions, because there's always a lot of questions with this, and you not asking questions scares me. So I'm going to work another problem, and if you don't understand something, speak up. That's why you're in the class. Remember, it's your grade. It's not my grade. So if you have questions, make sure you ask me. Let's do another problem. So once again, they say solve and graph. This time we're looking at a cubic. And see our inequality this time has an equal sign. So the first thing we want to do is set it to 0. So what I'm going to do, I'm going to subtract 4x from both sides, and I'm going to subtract 4 from both sides, and there I did what I was supposed to. So there's the first step, put a 0 on one side. The second step is we want to take the inequality out and set it equal to 0 so we can find the critical points. So we'll deal with the negative. When I start testing, we'll deal with the less than or equal to. Because this means infinite solutions. This means 0, 1, or 2 solutions. All right, so here we go. Now this looks like grouping to me, so I'm going to pray that I can do grouping 2 by 2. So I'm going to take out an x squared times what is that? X. X squared times what is that one? I'm going to take out a negative 4 times what is that? X. A negative times a positive, my cakes match. X squared minus 4 times x plus 1. And this can be factored again, right? We should have 3 solutions. So what is this factor to?
X plus 2, x minus 2.
All right, so what are our 3 critical points? Because we have a cubic.
-2, 2, and -1.
That's correct. Now, if this was an equation, we'd be done. Those are our solutions, done, graph them, done. But now we're looking for infinite solutions. So now these guys are critical points, and we want to put them on a number line so we know what to test. So this is step number 3. So I'm going to make a line at -2. This is not an asymptote. I'm going to make a line at +2 and a line at -1. So now we're going to test some points. So what number do you guys want to pick?
Zero.
So I'm going to test 0, 2 into this. So now we're dealing with inequality. So this would be 0 cubed plus 0 squared minus 4 times 0 minus 4. Is that less than or equal to 0? So is -4 less than or equal to 0? That's true. That means those are solutions. And now I'm going to pick a number over here like 3. So this time I have 3 cubed plus 3 squared minus 4 times 3 minus 4. Is that less than or equal to 0? Well, this is 27 plus 9 minus 12 minus 4. So this would be, I'm going to add the positives, 36 minus 16 is 20 less than or equal to 0. Okay, that's false. Do you want to guess what these two are? If this is false, true, you want to guess what that is and what that is? Like if we tested negative 1.5, what's going to be?
True.
If this is false, true, what's this one going to be?
False.
Uh-huh. And this one's going to be true because they're alternating. And if you want to test another one, go ahead. If you want to test negative 3, it's going to turn out to be true. So now what we have here is we have closed and closed. Those are solutions. And those guys are solutions. So here's what we're going to write. We're going to write negative infinity up to negative 2 closed, or closed on negative 1 up to 2 closed. And our solutions on the number line. So that up there is just helping me to graph. The solutions on the number line are going to be closed on negative 2, shaded with an arrow. So that's infinite solutions. And closed on negative 1 up to 2 in there would be infinite solutions. And how I'm coming up with this, I'm just looking at this. Arrow up to negative 2 closed, or closed on negative 1 up to 2 closed. I'm just looking at that. Okay, any questions? Now, the next time I meet with you is on Thursday, and this is going to be way harder. This is solving a rational inequality, which is the other part of this lesson. I'm not going to teach it today because I decided that I'm not going to confuse you. I'm only going to focus on this today. All right. Anybody want to ask me a question? Okay, let's do, what we're going to do now is we're going to do a problem out of your book, and I'm going to kind of guide you through it, but I want you to do the work. So make sure you have paper and a pencil, and I'm going to take you step by step through it. Everybody look at your book on page 412. Okay. Do you notice numbers 1 through 4? They already did the factoring for you. And they already put the 0 there for you. So it's less work. On problems 5 through 8, they didn't factor yet, but they have the 0 there. So they're kind of starting easy and they're getting harder and harder. All right, so let's do a problem together. So let's do number 5. I'm on page 412. All right, well, they already got the 0 there. So the first thing we want to do is set it equal to 0 or put the 0. So that's the first step, already done. Make sure you have this in front of you when you're doing it. So the first step is already done. The second step says set the numerator and denominator equal to 0. Oh, no, that's the other one. Sorry, it's kind of similar. So we already did it. Now we're going to solve for the equality. So we're going to take this and set it equal to 0 to find the critical points. Now, can you guys see that this looks like factoring method 5? The one that's a special case? So what multiplies to give 4 and adds to give -5?
-1 and -4.
Right. So we're done. So what are your critical points? What makes that 0?
4 and 1.
So now we're going to use the critical points to divide the number line into parts. So I'm going to draw a line through 4 just to see how it divided into parts, and 1. All right. So what you want to do is you want to test points in these intervals, and I would do at least 2 of them. You have 3 to test, 1, 2, 3 parts. What do you want to test?
2.
You don't want to test 0? Okay, we'll test 2. So 2's in here. So we're going to put it into this now. So we have 2 squared minus 5 times 2 plus 4. Is that greater than 0? Is 4 minus 10 plus 4 greater than 0? Now 4 plus 4 is 8 minus 10. Is -2 greater than 0? That's false. So put an F on 2. That means they're not solutions. All right, pick another number to test.
-1.
Victor, don't you want to pick 0?
Yeah.
Okay, you go ahead and pick -1. You pick -1. I'm going to pick 0. So this would be 0 squared minus 5 times 0 plus 4 greater than 0. Look at the wrong one. This one up here. So is 4 greater than 0? True. So what does that mean? Victor picked -1. I picked 0. What does that mean? They're both true. What does that mean? Go ahead, I'm listening. What does true mean? Doesn't true mean
They're
these are
solutions?
solutions? Yeah, they're solutions. So I'm just going to do it right now. It means these are solutions. Let me get another color. This is greater than, so it's open. Okay, now what do you think's over here? Do you think this is true or false?
True.
It is true because it's a quadratic and it's shaded on the outside, so it means this. And if you want to test it, go ahead. So now we're ready to write our solutions. So our solutions are negative infinity up to 1 open, or open on 4 to infinity. All right, so now we're going to draw the number line. And this is our solution graph, and you could even use this one if you want. It's going to be color the arrow in for negative infinity up to 1 open, open on 4, and color in the arrow for positive infinity. So this is your solution set of infinite solutions. And this is your graph. So remember, false means they're not solutions. True means it means they are solutions. And there's infinite solutions. So there's infinite solutions over here: 0, -1, -1.5, -1 3/4, -1 7/8, 5, 6, 7, 8, 9, 10.5, 10 square root of 2, 11.5, 11 24, 25ths, a million. So there's infinite solutions, but the numbers in here are not solutions because they failed. Okay, let me just check the answers to make sure they're right. Okay, this is right, and this is exactly what my answer key has. Okay, now here's the deal. What if this doesn't factor? You have to use the quadratic formula. So I want to do a problem like that so you can see it. Okay, does anybody want to ask me about this?
So like when there's like it's alternating on the graph, it's safe to assume the other section if it's true or false.
It's not really safe, but just to eliminate a lot of work, I'm telling you in this class right now, these problems, it's going to be safe. But in higher level classes, you would want to check all 3 sections. So I'm just trying to cut down the work for you. But to answer your questions, it's not safe. Because if this was like a higher degree, like a 4th degree or 6th, it could be different. For you guys, it's safe right now to say that this alternates. See, I can't swear to you that it's going to always alternate, and you don't know enough about them to make that assumption. So no, it's not safe to assume that. But I've worked enough with quadratics and cubics to know it alternates like that. Okay, let's do a harder problem. This one doesn't look hard. Number 25 looks like an easy problem. x squared quadratic less than or equal to 4x minus 2. And somebody asked me last period what side you want. I'm going to put them on the highest degree side. So if you subtract x squared, you're going to have to multiply both sides by a negative and flip the symbol. So I'm going to subtract 4x from both sides, and I'm going to add 2 to both sides. And there's my setting it on one side to 0. So now I'm going to find the critical points by setting it equal to 0. And guess what? You can't factor this. Nothing multiplies to give 2 and adds to give negative 4. So we have to use the quadratic formula. So on scratch paper, we have x is equal to negative of a negative 4. X is equal to negative b plus or minus square root b goes in parentheses b squared minus 4ac all over 2 times 1. So this turns out to be 4 plus or minus the square root of negative times a negative 16 minus 8. Now, that's going to turn out to be the square root of 8, which is 2 radical 2. When you do a prime factorization. And now you can cancel the 2, cancel the 2, and cancel the 2. So this is going to be x minus something, product of factors. X minus something else equals 0. What is the something? 2 minus radical 2 and 2 plus radical 2. So what are your critical points, you guys? Two minus radical 2, and what's the other one? Now, in order to graph this, you're going to have to put these in the calculator. So go ahead. I need 2 answers. I need to know what 2 minus radical 2 is, and I need to know what 2 plus radical 2 is. And I'm going to erase this over here, the quadratic formula. Okay, I need the answers here. What is 2 minus radical 2 on the calculator, and what is 2 plus radical 2?
For 2 minus radical 2, I got 0.585.
0.5 to what?
0.585.
So it's about 0.59. That is correct. Okay, what is this one? What's 2 plus radical 2?
.414.
About 3.4, that's correct. So now what we're going to do is we're going to graph these guys. So this is about 6/10, and this is between 3 and 4. So you have to know where these go. So -1, 0, 1, 2, 3, 4, 5, 6. Okay, this one is about 3.5, not quite. So I'm just going to draw something close. This one is 6/10, so 6 out of 10 parts. And I'm just going to write these down here. So this one is 2 minus radical 2, and this is 2 plus radical 2. All right, now, luckily, when we test, we don't have to test these ugly numbers. We can test integers. So I'm going to test 0 because I like it. So this is what we're putting it into. So 0 squared minus 4 times 0 plus 2, is that less than or equal to 0? Is 2 less than or equal to 0? That's false. So this is false. Okay, now I'm thinking that this section is going to be true, so I'm going to pick 1. So now I have 1 squared minus 4 times 1 plus 2. Is that less than or equal to 0? Is 1 minus 4 plus 2 less than or equal to 0? This is negative 4 plus 3 because I'm putting the positives and the negatives together. So is negative 1 less than or equal to 0? True, just like I thought. So what do you guys think this section is over here?
False.
All right, so we're ready to write the answers. Let me graph this really quick. So this is less than or equal to, so this is closed, and it's shaded on the inside. So it's going to be closed on 2 minus radical 2 up to 2 plus radical 2 closed. That's an exact answer. Now, on your online test, I don't know what they're going to do. So if they put an exact answer, it's going to be that. If they put an approximation, it's going to be closed on 0.59 up to 3.4. And only you, by practicing, is going to know which one they're going to put. Now, I like exact answers. That's an approximation. And then the graph, it's closed on 0.59, which is about 0.6, which is 6/10. And it's closed on about 0.6, or I'm sorry, 3.5, which is about 3.5. So like I said, I would have these in front of you. You're going to put a 0 on one side. You're going to solve the equation to find the critical points. You're going to use the solutions as critical points to separate the number line into parts. You're going to test values and then write your solution and graph. Now, this was not a nice problem, and the reason why is that didn't factor. So we had to use the quadratic formula, and notice that you don't see the quadratic formula up here because it's busy work, because you have to do it on scratch paper because I don't want to see it. So I just want to see the work at hand now. I don't need to see the quadratic formula. That just adds to the confusing stuff. All right, anybody want to ask me a question about this? All right, would you like to work one more problem?
Yeah.
All right, why didn't you pick the problem? Because look write this down. I'm not going to post the assignment because I haven't taught the other part. So here's what I want you to do. In lesson 2.7, you should be able to do on page 412 and 413, 1 through 41 odd. Now, that's 20 problems, which means by Thursday, it's only 10 problems a day. You're going to even have more time than that. So I expect you to do this because in the next 2 days, because I'm going to teach something harder on Thursday. So once again, I'm not going to post the assignment yet because I haven't taught the second part of the lesson, but you should be doing this and you should be able to do it by Thursday. If you don't do it by Thursday, you're going to be really confused on Thursday because I'm going to be going over solving rational inequalities, which is worse than this. So what you don't want to do is, well, Miss Birch didn't post the assignment. I'll just wait until she does it. Okay, good luck with that. Because I'm telling you what I want. I want you to do 1 through 41 odd. All right, can I erase this right here? All right, somebody pick out a problem in the lesson and we'll do it. So either on page 412 or 413, 1 through 41 odd. Which one do you want to do?
$38.
Okay, pick an odd one. Pick an odd one so we do one in your lesson.
37.
Okay. All right. So what is it? X cubed. So it's a cubic. So we're expecting 3 solutions for the critical points. So 37 is minus 3x squared minus 9x plus 27. Did I write it down right?
Yeah.
Okay. So it's already got the 0, so that's our first step. The second step is set it equal to 0 and find the critical points. Now look at this. We're going to try to factor, right? And guess what? If we can't factor, we have to do that P over Q list. Now I hope we don't have to do that. So let's try to factor by grouping. So take out an x squared and you get x minus 3. Over here, take out a negative 9. So a negative times a positive, and thank goodness it worked. It worked. All right, so we get x squared minus 9 times x minus 3 equals 0. What's your product of factors?
X minus 3 and x plus 3.
Yeah. And another one, right? All right, now, do you guys understand what's going to happen here? Is we have multiplicity, which means we can't assume it's going to be true, false, true. So multiplicity is going to change things. So our solutions are negative 3 and 3, but that has a multiplicity of 2. Now, those are our critical points. Let's continue. All right, so we're going to draw a number line and graph our critical points. All right, I'm going to be real careful this time. So I'm going to pick 0 again. And we're putting it into this, guys. So it's going to be 0 cubed minus 3 times 0 squared minus 9 times 0 plus 27, is that less than 0? So that 0, 0, 0 is 27 less than 0. That's false. So this is false. And now I'm going to try 4. So this is going to be 4 cubed minus 3 times 4 squared minus 9 times 4 plus 27. Is that less than 0? So I might need some help. We'll see. So 4 times 4 times 4, that's 64. 16 times 3 is 48. Minus 36 plus 27. So 64 and 27 is 91. And a negative is a negative, and you add 14, that would be 84. So is 7 less than 0? False. And it's exactly what I thought. The multiplicity caused it not to alternate. Let me just check the book to make sure. So how did I know this? I didn't know this. I was just guessing. See how the multiplicity messed this up? Luckily, we only have one more to do. We're going to test -4, and I hope it's true. So this is going to be -4 quantity cubed minus 3 times -4 quantity squared in parentheses minus 9 times -4 plus 27 less than 0. So this time, this is going to be a negative times a negative times a negative is -64. This is a positive 16 times a negative is -48. This is a positive 36 and a positive 27. So now we have a negative and a negative is negative, what? 112 plus 63. Can somebody tell me what's 112 minus 63? It's a negative. 112 minus 63, somebody?
Negative 49.
Okay, that's true. So look it. So check this out. This is going to be open going this way only. And the only reason it did that was because of the multiplicity. So our solutions are -infinity up to -3 open. And the graph is open to the left forever. So it's just like what I thought. The multiplicity caused it not to alternate. And I am looking at the answer in my book, you guys, and this is correct. Now, notice that whoever picked this problem, it was at the end of it was one of the hardest problems. So I wouldn't give you a problem like this on the exam. But this would be one of the hardest problems you'd have. So this is the video I'm going to post on YouTube because I want everybody who's watching it to see this weird problem. I did not do this in period 1. So what led me to believe this? You tell me, what led me to believe that I have to test all 3 parts?
The multiplicity of the negative.
This up here. So see how I only wrote the 3 once because this had a multiplicity of 2? So remember the graphing, like we graph in 2 dimensions. This is a cubic, it looks like a snake. So at -3, it's crossing, but at 3, it's touching and turning. So what this is saying is it's saying these are not solutions. It's only to the left of -3 that are solutions. And the reason, like I said, the reason why we're graphing on the number line, there is no y. I'm just showing you if there was a y. So that's why we're graphing in 1 dimension, because there is no y. So in other words, we're not concerned about the range. We're only concerned about the x values. All right, so that's the lesson. I'm going to end it right now. So I'm going to stop the recording. If you want to hang out and ask me questions, or if you're confused about something, that's fine. But make sure you do 1 through 41 odd in the lesson 2.7, which I haven't posted yet, but I want you to do those problems. All right, so I will see you. If you want to ask me some questions, I will hang out.